Hello and welcome friends. In this video we discuss about the higher order derivatives. Friend, you are familiar with the definition of derivatives and we know that how to find the derivatives, but sometimes we need to find the derivatives higher than the first. When we differentiate a function y equal to f of x, we get dy by dx. Then whenever we differentiate once again this dy by dx, we get d2y by dx square. If we continue this process and if we differentiate n times, we get dny by dx raised to n. So these derivatives are called as higher order derivatives. That means here if we y equal to f of x, then the function or then dy by dx d2y by dx square d cube y by dx cube dash dash dny by dx raised to n. These are the successive derivatives or higher order derivatives. Whenever we have a function f, sometimes its derivative we denote by f dash. This is the first derivative. Second derivative we denote is by f double dash. Triple derivative f triple dash. Likewise, so these are the higher order derivative or successive derivatives. Again we have another notation to write the derivatives. Y, whenever y is a function, then we write y1 to denote the dy by dx, y2 denote the d2y by dx square, and yn to denote the dny by dx raised to n. So these are the different types of notations we are using to denote the successive derivatives or higher order derivatives. So friend, let us see how to find the higher order derivatives. If we see with an example, suppose my function is x equal to a into cos theta plus theta into sin theta, and y equal to a into sin theta minus theta into cos theta. Then find d2y by dx square. Here you can see that y and x are the functions of theta. So this is an parametric form. Hence first we differentiate this dx by x with respect to theta. So dx by d theta equal to a into derivative of cos theta, as we know this is minus sin theta, plus here we need to apply the product rule. Derivative of the first function theta with respect to theta is 1 into sin theta plus theta as it is into derivative of sin theta, this is cos theta, and dy by d theta equal to again a into derivative of sin theta is cos theta minus derivative of theta is 1 cos theta as it is minus theta into derivative of cos theta, we get minus sin theta. Okay, so here you can see that this minus sin theta and sin theta get cancelled and we get a into theta into cos theta. This is dx by d theta, and here cos theta get cancelled, minus minus plus, and we have a theta into sin theta. Now we need to find d2y by dx square. So we write dy by dx equal to dy divided by d theta whole divided by dx divided by d theta get cancelled. Okay, and this is a theta sin theta divided by a theta cos theta. A theta get cancelled, and we have this is a tan theta. Okay, this is dy by dx. So differentiate this with respect to x. This is equal to d2y by dx square. So this is d by dx of tan theta. You can see that tan, this is a function of theta, but we are differentiating with respect to x. So we change the variable d theta into tan theta into d theta divided by dx. D theta get cancelled. Now we can find, we can obtain the derivative of tan theta. Derivative of tan theta is sec square theta into d theta by dx. We have dx by d theta is a 1 a theta into cos theta. So this is 1 divided by a theta into cos theta. Again 1 by cos theta is a sec theta. So here sec cube theta divided by a theta, and this is the second derivative d2y by dx square. Let us see one more example of this higher order derivatives. If y equal to sine of sine x, then prove that d2y by dx square plus tan x into dy by dx plus y into cos square x equal to 0. This is we want to prove. Here you can see that we need second order derivative. Therefore, we differentiate this y two times. When we differentiate this with respect to x first time, we get dy by dx equal to derivative of this sign. Derivative of this sign is cos of sine x into derivative of this sign. This is cos of x. Okay, so we have applied the chain rule. Now again differentiate this, we get d2y by dx square equal to derivative of cos. We need to apply the product rule. Okay, this is first function and this is second function. Second function as it is, first we find the derivative of first function. Derivative of cos is minus sine of sine x into derivative of cos into derivative of this sign. Derivative of this sign is cos of x, but already we have one cos of x, so cos of x into cos of x, we get cos square x plus cos of sine x into derivative of this cos, that is a minus sine x. Okay, so you can insert bracket so that there will be no confusion. Now here you can see that let us write this d2y by dx square plus tan x into dy by dx equal to, let us calculate this. What is d2y by dx square? Minus sine of sine x into cos square x minus cos of sine x into sine x plus tan x into cos of sine x into cos x. Okay, what is the tan x? Tan x is sine x divided by cos x. So this tan x, for this tan x, sine x divided by cos x, this is equal, you can see tan x equal to sine x divided by cos x. Okay, so cos x and cos x will get cancelled and we remain with sine x. This is equal to minus sine of sine x into cos square x minus cos of sine x into sine x plus cos of sine x into sine x. Okay, here minus and plus this is cancel, and for the sine of sine x we write y, this is equal to minus y into cos square x. Now let us transfer this term to this side. Then we get d2y by dx square plus tan x into dy by dx plus y into cos square x equal to 0. So we have proved that by obtaining the successive derivative 2 times of the y, we have proved the inequality. Let us see one more example so that your idea of successive differentiation will be cleared. Let us once more prove likewise a simple example. You can see I have this: if y equal to a into cos of log of x plus b into sine of log of x, then show that x square d2y by dx square plus x into dy by dx plus y equal to 0. We need to show this equation, and here you can see we need to find second derivative. Okay, therefore we differentiate this dy by dx equal to a into derivative of cos is minus sine of log x into derivative of log is 1 by x plus b into derivative of sine is cos of log x into derivative of log is 1 by x. Let us multiply throughout by x so that we get x into dy by dx equal to minus a into sine of log x plus b into cos of log x. We need a second derivative. Okay, therefore we again differentiate these equations once again. Here we have x into dy by dx. Therefore x into derivative of dy by dx, that is d2y by dx square, plus derivative of x is 1 into dy by dx equal to minus a into derivative of sine, that is cos of log x into derivative of log is 1 by x plus b into derivative of cos minus sine log of x into 1 by x. Okay, so this is in the multiplication. Do not bother about this multiplication and minus, right? Now again multiplying throughout by x, we get here x square into d2y by dx square plus x into dy by dx equal to here minus a into cos of log x minus b into sine of log x. If we take minus sign common, this is equal to minus y. Now transfer this minus y to right side and we arrive at x square d2y by dx square plus x into dy by dx plus y equal to 0. So this proves the result. When y equal to a into cos of log x plus b into sine of log x, then we have proved this x square into d2y by dx square plus x into dy by dx plus y equal to 0. Now let us consider one more parametric equation where we need to find the derivative. If x equal to f of t and y equal to phi of t, then prove that d2y by dx square equal to f1 phi 2 minus f2 phi 1 divided by f1 square. Here the suffixes f1 means first derivative, f2 means second derivative, phi 1 first derivative of phi and phi 2 second derivative of phi. Here you can see that dx by dt equal to f dash dy by dt equal to phi dash, or here instead of dash we write it as f1. Here phi 1, since we are using the suffixes to denote the derivative. Now dy by dx equal to dy by dt divided by dx by dt. This is equal to phi 1 divided by f1. Now we need to find second derivative. So differentiating this, d2y by dx square equal to d here this here is a f cube. Okay, d by dx of which term? Phi 1 divided by f1. But phi and f are functions of t, therefore we write it as d by dt of phi 1 divided by f1 into dx dt divided by dx. Here is a dt. Okay. Now apply the u by v rule. f1 into derivative of phi 1, that is phi 2, minus derivative of f1, that is f2, into phi 1 divided by f1 square into 1 divided by f1. So we get here f1 phi 2 minus f2 phi 1 divided by f1 cube. So this proves the results. I hope you have get the idea of how to find the higher order derivative. Thank you friend. Thank you for watching the video.